All right, so we're working through this problem with a lot of moving pieces. So the problem is you're flying from Joint Base Lewis McChord to an undisclosed location 219 kilometers south and 172 kilometers east. Mount Rainier is located 56 kilometers east and 40 kilometers south of the base. If you are flying at a constant speed of 800 kilometers per hour, how long after you depart the base will you be closest to Mount Rainier? So we're going to start with a picture. And we're going to think of it in terms of the coordinate plane. So if we were to map this out so imagine taking a map of Washington State and then putting the coordinate plane on it. So that's what we're going to be doing. So let's do that. And then we want to think in terms of our compass rose. So I'll put this in the corner. We can remember here. Northeast, southwest. Perfect. So that'll just help us reference the directions. So we're starting at Joint Base Lewis McChord. So we get to pick where that is on our coordinate plane. And I'm going to just put that at the origin. So we're going to assume that this is where we start. This is Joint Base Lewis McChord. And its coordinates are 0, 0, because it's the origin. And so we're flying to an undisclosed location, and I'll label this UL. 219 kilometers south and 172 kilometers east. So we can think of south and north as up and down on our y-axis. So if this is y and this is x, you can think of up as positive y and down as south. So if we're going 219 kilometers south and 172 kilometers east, then we can also think that the x-axis is east and west. So if we're doing positive on the x-axis, we'll move to the east. If we're doing negative, we'll move to the west. So 172 kilometers east would be positive. So say somewhere around here. And then we're moving 219 kilometers south. So let's say we're somewhere around here, where this is negative 219 on the y-axis. And this is positive, where is it? 172 on the x-axis. So this is our undisclosed location at the coordinate point 172, negative 219. Okay. And so the train is traveling, or the plane is traveling in that line. So we can connect the two dots. So that's the route that our plane's going to take. And so now if we wanted to plot Mount Rainier, we know that Mount Rainier is 56 kilometers east. So again, that's positive on the x-axis. So let's say that's somewhere like right here, 56. Oops. And 40 kilometers south. So south again is on the negative y-axis, so negative 40 about here. So Mount Rainier will be somewhere right here at the coordinate point 56, negative 40. Cool. And so now there's a lot of pieces to this. We're going to ignore the constant speed for right now. We'll come back to that later. But it's telling us that we want to find where Mount Rainier is closest to our flight path. So our flight path is the green line, and we want to find where Mount Rainier, so this purple dot, is closest to that green line. And if you remember from geometry, the closest that a point can be to a line is if it's perpendicular to it. So we'll draw a perpendicular line from Mount Rainier to our flight path. And then we'll just label it with a nice right angle symbol just to show that it's perpendicular. Okay, so what we need to do is figure out what this point is, because then we'll be able to figure out how long it'll take us to get to that specific point. So I'm going to make it a different color. Let's do it in red. So we need to figure out what this XY is. So to do that, we need to figure out where those two lines intersect. So the purple line and the green line. Our flight path is the green line. The purple line is the closest point from Mount Rainier but we've drawn a line. So if they're perpendicular, we know that their slopes have to be opposite reciprocals. So let's first find the slope of our flight path. So we'll call it the slope of flight path. And remember our slope equation is, I'll write it out over here. In general, y2 minus y1 over x2 minus x1. So if we wanted to find our flight path or our slope for the flight path, we'll take our y value for the undisclosed location, which is negative 219, minus the y value of our base, which is 0. So we can actually just, we could write minus 0, but we know that anything minus 0 is itself, so I'll just leave it like this. And it'll be the same for our x change. Since we're going from 0 to 172, the change will just be 172. So that's our slope for the flight path. Now, if we want to find the slope for the purple line, we just flip it and make it negative because it's opposite reciprocal. So we'll call this Mount Rainier line. It's going to be 172 over 219. Perfect. So now what we have to do is figure out the actual equations of those lines. So we'll start with the flight path. Notice that the flight path actually crosses the y-axis at 0. And that's because we said, well, we're going to make our origin the base. So our y-intercept is actually 0. So the equation of our line is going to be negative 219, which is our slope, x, plus 0 is our b, so I just won't write the plus 0. So that is the equation for that line. For the purple line, we'll write this out. We know our slope is 172 over 219, and then x plus b. So we have to figure out what b is. So that would be wherever the line crosses the y-axis, so this point here. Now, luckily, we do know one point on that line. We know where Mount Rainier is. It's 56, negative 40. So what we can do is plug in our xy coordinate and solve for b. So I'm going to make myself a little bit more room. Okay. So we know y is negative 40. We know our slope. And we know x is 56 plus b. Now, normally I would encourage you to not use decimal answers in your equations. However, I've worked this one out and it does not end up being very nice or reduced nice at all. So I will be using decimals just for the sake of time. So if we were to solve for b, we would remember that 56 is technically 56 over 1. So we'll multiply across the top, 172 times 56. And that gives us 9,632. And then we also have 219 times 1. And anything times 1 is just itself. So 219 plus b, negative 40. And then we can, I'll write this as the decimal, just so it's a little bit easier. So we have negative 40 is equal to, 9,632 divided by 219. It's going to be approximately 43.98 plus b. And then what we want to do is subtract 43.98 from both sides to solve for b. So negative 40 minus 43.98 gives us negative 83.98 is our y-intercept. And that makes sense. I mean, that looks about right. It's in between 40 and 219. So this point would be 0, negative 83.98. And the equation of our purple line would be y is equal to our slope, which is 172 over 219x, minus 83.98, our y-intercept. So we have the equation of our purple line. We have the equation of our green line. So now we're going to need to graph both of those.